Okay, continuing with our section on trigonometry now. We've been solving equations and looking at the four quadrants and different things like that. We're now going to have a look at the graphs of the trig equations, and we're going to do that with the aid here of a little nifty piece of software. What we're going to see here is, as I drag this slider across, this point P is going to be dragged around the unit circle which we've got here, and the x and y coordinates are being plotted. Okay, so along the x-axis here, we've got the angle that's been created here at the center, this central angle, which at the moment is 48 degrees. You can see where that point there, I think, see that black dot? That's right on the angle that we've currently got plotted. So that's whatever that is at the moment, 120, which is right there on the x-axis. So on the x-axis, we've got this angle here, and on the y-axis, we've got two graphs being drawn simultaneously. This red is plotting the x-coordinate of P, and this aqua sort of colour, this turquoisey thing, is plotting the y-coordinate of P for this angle. Okay, so as we move through, you can see that we're getting a couple of curves going, and because this is the x-coordinate, the red is the x-coordinate, that's the cos curve, and the y-coordinate is this turquoisey colour, that's the sine curve. And if I animate that, I can sit back and we can watch this thing develop. Okay, so the cos curve in red and the sine curve being created. Okay, we've just about filled that in nicely, and it's going from sort of 0 to about 1000 degrees. As you know, just take that animation off. So at the moment it's at 227 degrees, or actually it's at 600. No, so that's not correct. It's at 681 degrees, and you can see those. And because it's got the cyclic nature, it just keeps peeling over itself, and we keep resetting at 0 to 1000. So there's our curves. What we're going to do is go back and have a look now at just getting a sketch of those. So for the sine curve, sometimes called the sine wave. Okay, we're just going to graph. We're going to graph this from 0 to 360 degrees, and from 1 to -1. Obviously, that's their extremities on the y-axis. And if we go back in here, we can see that the sine curve here starts at 0, 0, goes through 180, and picks up there at 360. So it's just going to be, if we can get, I might go for, so 180 degrees, 90 degrees, 270 degrees. So we're going to be going up to at 90 degrees, is that right? 90 degrees, 180. At 90 degrees we've got sine equals 1, so it'll go through there, and it'll come back. So it goes through the x-axis here at 180 degrees, and it'll go through here at -2 at 270. It'll be -1, and that's where we've got 360 degrees there. So that's y equals sine x from 0, sine x for x being from 0 to 360 degrees. That's that curve. So that's the sine shape along that domain from 0 to 360. So if we do the same now for the cos curve, again we'll just look at the from -1 to 1, from 0 to 360, and we'll break it up into our quarters. And the cos curve starts up here at 1, because cos of 0 is 1, as you know, and has this bell sort of shape appearance. It's inverted bell appearance through to 360 there, going through at 90 and 270. So our curve is going to come down from 1 through at 90 degrees. It's going to bottom out here at 180 at -1, back through at 270 degrees, and it'll be starting its, just need to fix the end up there, I've gone beyond 1. It'll be starting its drop back down here at 360. So it'll be in there like that. That's roughly good enough. Y equals cos x for x from 0 to 360 degrees. Right there. So they're the sine and cos curves. The only thing I need to go through with you now is how to use the graphics calculator in order to solve trig equations. So we're going to look at the example on page 465, and we're going to solve cos theta is equal to 0.4 for theta between minus 360 degrees, and 360 degrees. Okay, so into our calculators. That's not a calculator. That's a calculator. Okay, bring up the graph screen, and what we're going to do is we're going to put in here. We're going to graph our cos curve. So cos x, if you don't mind. There it is there. Now I'm not really that happy with that, because what I want to go from minus 360 to 360 on the x-axis here, and I don't need this 6.67 to minus 6.67. So I'm going to go into my menu and change my settings here. I'm going to change my graphing angle to degrees, because that's what I'm working in, and hit OK there. That's my graphing angle. As you can see, that's all messed up now. But what I'm going to do now is go in and have a change of my window. My window settings are going to change. So that's going to be minus 360 to 360. So bear with me while I get that in place. Minus 360. We'll tab down to 360. We'll tab down. I've lost screen. The X scale there is going to be 45. So I'm just going to put 45 in there. My Y min is going to be Y min is going to be minus 1.5. Would be a good option there. There we go. I need my screen back again. Minus 1.5. Minus 1.5. We tab, and we want 1.5 in there. So we go to. You'll do yours a lot quicker than this. Tab, and the Y scale we want to be 0.45. So tab 0.5. Drop that down. Hit OK. Okay, so there's our cos curve, and now you can see we've got it in degrees, and that's nice. Okay, what we need to do is also graph 0.4. So that'll be a lot easier for us. Y equals 0.4. One would think it would be a lot easier. Hit enter. Okay, so what we've got here is the cos curve. So we've got cos x, we've got y equals 0.4. So the intersecting points there, which there are 4, they're my solutions. So go into menu, analyze graph, find the intersecting points, and make notes of them. So that one's at minus 294. So that is one solution. Minus 294. We're going to go and do that over. Again, we're going to do that 4 times. The intersection, bring up the next solution is at minus 66.4. So we do that twice more, and we'll have the solution to the equation cos theta equals 0.4. So what I'd like you to do is go ahead and, using the CAS calculator, find the solutions. So if I could leave that with you, just to save time, we've got minus 294 and minus 66.4. So I'll start you off minus 294 degrees and minus 66.4 degrees. And then you've got 2 more to find. Okay, just to have a look at the next example, just slightly different in that we're going to solve to radians now. So solve sine theta equals, or sine x equals 0.25x. Sorry, 0.25, sine x equals 0.25x minus 0.3. 0.25x minus 0.3. I need to change that theta there to x. So sine x is equal to 0.25x minus 0.3. So what we need to do now is go back into our calculators. We need a new, we need a Escape that, escape that. So I think Control N will give us a new graph. So in here we're going to sketch sine x is going to be one of our curves. So go into, you just type in sine, if that's easier for you, sine bracket x, close, hit enter. Now again, we're not going to be pleased with that, so we're going to go into menu, settings. Now we're going to change to radians. We've got it in radians, it's perfect. Our graphing angle's in radians, so that's okay. But we're going to want, I don't know why mine's floating around like that, we're going to want it from minus 2 pi to 2 pi. So into our window, we're now going to change our window settings to, in there, that'll be 2 or minus 2 pi. So we'll put minus 2, and your pi button is down here somewhere, is it not? Where's pi? Oh, there it is there. The pi button is down here if you don't mind. Minus 2 pi, there it is. Minus 2 pi, so we go through the same process there. Put in your, I'm having all sorts of trouble with my machine here. Change your window settings. Your X scale will be pi on 4, your Y scale will be 0.5, Y min minus 1.5, Y max 1.5. You will also need to draw the straight line 0.25x minus 0.3 and find the points of intersection as we did before. Okay, hopefully that'll be alright for you now, and you can move on to exercise 13G at the appropriate juncture. Okay, see you soon.